Hey everyone, welcome to today's video. In this session, we'll dive into exploring sorting and searching algorithms. We'll go through a practical exercise to see how we can implement linear and binary searches and compare and contrast the two. Let's read the scenario here in Markdown. So let's imagine we're looking for a specific book in a large library. The endless rows of shelves can be overwhelming, and finding that one title can feel like searching for a needle in a haystack. We'll learn how to use Python to make searching a digital library much easier and more efficient. We'll explore sorting algorithms, which organize book data in a logical way, just like arranging books on a shelf. Then we'll explore search algorithms. These are like having your own digital librarian to help you quickly find the exact book you're looking for. So first, let's look at the two CSV files that we're going to be working with. So I'll turn your attention to the first one, which is going to be book catalog 10. And here is just 10 books. So the column is going to be, there's going to be 3 columns: title, author, and publication year. And the next one we're gonna use is called Big Book Catalog, and this has a ton of records, so I'll just scroll down for you. And we have, I guess I could do Command down. We have 271,380 records here. So, but it's the same: title, author, publication year. And so we're going to use these CSV files to talk about searching and sorting algorithms. So first, let's import the first one, book catalog 10, and convert it into a dictionary. So here we'll write and then we're going to do the read CSV function. Book catalog df. df is data frame. pd.read CSV, and then this is the name of the CSV file. And we want to convert the data frame into a list of dictionaries. So here we will do book catalog is equal to book catalog df dot to dic orient is equal to records. So this orient parameter converts each row of this data frame into a dictionary. And let's see the result of this list of dictionaries. And then we'll run it. So as you can see, it's an organized list of dictionaries. Title, author, and publication year is one dictionary. And so each row is captured in its own dictionary, and it's a list of all of them. So this is going to be 10 dictionaries because this file has 10 records. So it's pretty unorganized right now, so it's not sorted. So let's try and sort this. So I'm gonna create a couple of helper functions to sort this. So first, let's do this is going to extract the title from the book dictionary. So we're going to return book title. And then we're going to create another function called sort catalog by title. And the parameter is going to receive the catalog, the dictionary that we just created above. So we're going to try and sort this alphabetically by title. So to do that, we'll do catalog.sort key is equal to get title, and get title is this helper function right here to get that book title. Okay, and now we want to use this function, and so what we can do is call it. So book catalog right here, we defined it right here. It's this list of dictionaries. And we want to display this sorted catalog. So we can use a for loop for book and book catalog. Print, we'll use an f string, title, publication year, book, publication year, okay, so it should print out each book sorted. We'll run that, and it looks to be sorted, so this numerical number 1984, H, P, T, and so forth. So now our book catalog is sorted by alphabetical order, by title. But what if you wanted to find a book without scanning the entire list? And this is where search algorithms come in. They help you pinpoint specific items within a data set. So first we'll explore how to implement what's called a linear search, which will systematically check each book. So we'll go here and write a function called search books catalog query. So it's going to take two parameters. So catalog is going to be the list of book dictionaries, and query is what we're going to be searching for. And in this case, we'll search for either the title or the author. So we're going to create an empty list first, and we're going to put in the results in there afterwards once we capture it. And you'll know what I mean later on in the video. So we define an empty list called results, and then we're going to go through each book in the catalog. So for book and catalog, if query.lower in book, and I'll talk to you about why we're using lower. Or query.lower in book author. So we want to use lower to make the case insensitive. So if the user puts in a query that's a lot of capital letters or a mix of the two, and it doesn't exactly match, then we're not going to get a hit. So that's why we're changing everything to lowercase to make it case insensitive. So if query.lower in book title or in author, so it's checking for book title and book author, then we're going to results.append book. So if it's a match, then we're going to put that in this results list. and then we're going to return results at the end. So let's run it. So now our function is ready to use, no errors. So let's implement the function by trying to search for the Great Gatsby. So here, the Great Gatsby is there, so it should work if we look for it. So let's define query is equal to the Great Gatsby, and then we can call this function right here. So we can do something like this: search results is equal to search books, and then we're going to put in the parameter book catalog and query. So book catalog we defined earlier here, so it's our list of dictionaries. And then query is what we define here, the Great Gatsby. Okay. So if search results, so if it's true, then do this. So print search results for book in search results, print Okay, we're going to print this f string, and then else. So if it's not true, if this doesn't get any results, then we're going to print no books found matching your query. And let's run this. So we got a hit because the Great Gatsby was found, and so it printed out this f string. So let's check to see if we put in a book that's not in here, and let's see the result. So let's see if this else conditional works. So I'm just going to copy and paste this in here, and I'm going to put Dune. We know that Dune is not in there, so it should print out this else statement. And we'll run it. And yes, it is what we were expecting. No books found matching your query. And so we did the book title, but now let's also try the author. So I'm going to copy and paste it again, and this time I'm going to put the query instead of the book title. I'm going to put J.K. Rowling. And in our CSV file, J.K. Rowling is there, so it should come up with a hit. So yeah, everything looks good, and we'll run it, and it's there. So we see the correct output using J.K. Rowling as the author. So this is the search algorithm that we used. It's working fine, but it could be slow if the library is huge. So binary search is a better algorithm to use in the event of a large list, because it keeps narrowing down the possibilities in half until you find what you're looking for. So we will create a binary search algorithm here. So once again, 2 parameters, the list of dictionaries and the query. So binary search books catalog query. So in order for this to work, we are assuming a sorted catalog. So this has to be sorted here, the catalog, for this to work. So we're going to define low is equal to 0. We first start by setting up boundaries. So 0, the beginning, and high is equal to length of the catalog minus 1. So the reason why we have to do minus 1 is because the index starts at 0. So we want to capture the length of, or the last index in the list. So that's what's going to be high, and low is 0. So we're working with indexes. So we can do a while loop here. So while low is less than or equal to high, mid is equal to low plus high, floor division 2. So mid is the index of the middle item. We're doing // here because this is called floor or integer division, and it returns an integer result rounded down. So for example, if we did 5 // 2, it's going to be 2, not 2.5. So we have to do this because we're working with indexes, and indexes are integers. So here, so we define what mid is. So now, so if catalog mid and then title dot lower. So if that index, the middle index title is equal to query dot lower. So if we got lucky and the middle index is actually the query, then we're going to return catalog mid. So that's if we got the right answer from the get-go. But most likely that's not going to be the case. So we do an elif. So elif catalog mid title dot lower is less than query dot lower. Then we're going to change our low, our bottom boundary to mid plus 1. So we do this to half the number of possibilities. And then, so we can either do this, we can do a greater sign here or less than. But if we do a greater sign here, then we would do the opposite. But we chose to do this, so we're going to do else is equal to high is equal to mid minus 1. So if we did a greater sign here, we would put this right here. But we just chose this one, so we're going to put the else statement as the opposite of this. And so, yeah, everything looks good. And then we're going to return none if the loop ends without a match. Then we know the book is not found. So, yeah, everything looks good. We'll run it. And no errors. So now that we have the binary search algorithm formed, let's see it used in the big data set that I showed you earlier. So I'll show it to you again. So this data set has 271,380 rows that we'll use to implement both the linear and binary searches. So we're going to import a library called time to calculate execution times for each. So let's see which one is faster. So first I'll start with the linear search. So here I'll do import time. We need this library to calculate execution times, as I mentioned before. And we're gonna do, it's kind of similar to what we did above. We just get it, read CSV, big book catalog df is equal to pd.read CSV. And then low memory is equal to false. So we do low memory is equal to false to prevent pandas from guessing the data type across chunks, avoiding certain warnings or errors. Okay. And then here, we're gonna do big book catalog title is equal to big book catalog df dot fillna dot as type str. Okay, so what I'm doing here is we're making sure that every entry in title in the title column are valid strings. So, and then fillna replaces any missing values with an empty string. So, and then this, the as type, it turns it into a string. And make sure that it's a string. So we want to do this for not just the title column, but also the author. So just copied and pasted, author. Okay. All right, everything looks good, I think. Yeah. And then now we do sorted df is equal to big book catalog df dot sort values, and we're going to do it by title. So we sort the data frame, and now we did just do what we did above. So we create this catalog. Now we call it a big book catalog. And we're going to take this sorted data frame and turn it into a dictionary, a list of dictionaries. So now we're going to perform a linear search. So our query is equal to the Great Gatsby. We'll use that again. And now we're going to start our timer. So we're going to do start time is equal to time.time. So this records our start time. And now we're going to perform the linear search. So search results is equal to search books. And then we're going to do big book catalog as our first parameter, and query is our second, which we defined above. And after we do this, we're going to do end time is equal to time. So we need to find the difference between these two to get the time elapsed. So what we do is elapsed time linear is equal to end time minus start time. And now that we have this, let's print linear search took okay, so we're going to say linear search took, and we're going to use this variable elapsed time linear, 0.5f. So 0.5f formats the floating point number to 5 decimal places. So if this answer is crazy long, let's say a ton of decimals after the decimal, or a ton of digits after the decimal, then it's just going to shorten it to 5 decimals. So if search results print for book in search results author publication year okay, else print okay, let's see, forgot the quotes right there. Okay, else print notebooks found matching your query. Okay, so it should work. And we get a, okay, book catalog, sorry. Okay, should be big book catalog. Okay, we run it again. Okay, so here we go. Linear search took 0.07834. So the 0.5f worked, it limited it to 5 decimals, so 1, 2, 3, 4, 5. So that's how long it took. And this is our result list. Okay, so this is our linear search. So now let's see the execution time of the binary search by using the binary search books function we created earlier. So we ran the function here, but we never got to see the use of it, or the result of it. So let's take this again. I'm going to copy and paste this, and I am going to use the binary search. So let's say, instead of using the search books right here, the search results, I am going to use the binary search books function. Okay, same 2 parameters. And I'm going to do changes from linear to binary. And then change this also to binary. And then we don't need this for loop because in our function, it's not going to be a list. So it's just going to put 1. So I'm going to take this out. So if search results, let's see. Okay, I'm going to put binary search result for The Great Gatsby. Okay. And I'm going to take away this for loop. Print title author, publication year. Instead of book, we're going to do search results because we got rid of that for loop. Search results. Okay. And then we'll just do binary search book not found. Okay. So this should work using the binary search books function. Run that. Okay, type error. Let's go to our function now. So it's going to be elif catalog line 9 door query.lower. Okay, 1 second. Okay, I found the error, so I forgot to put the parentheses right here. So let's run this again. Okay, works. Now let's run this guy. Okay, so it ran it for 0.07834 seconds. 1 second. Okay, I forgot to change this linear to binary. Sorry. Okay. Yeah, there we go. So it was a lot shorter, so 0.00010 seconds. And it's a lot quicker than the 0.07834 seconds. Okay. So that checks out. So to recap, we saw how to create a linear and binary search in an example containing thousands of books. So we looked into the process of how each algorithm works and how binary searches can yield faster results. Thanks for watching, and I'll see you next time.